Hey everyone, this is your math guru. In this video, I'm going to show you how to simplify the following trigonometric expressions using the cast diagram. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. We have if sine 40 degrees equals to P, write the following in terms of P. A sine 140 degrees. To start with, we've been told that sine 40 degrees is equal to P. Note that 40 degrees is an acute angle, and using a cast diagram, we are going to have that in the first quadrant. So if I roll my hypotenuse, I'm rolling towards my x-axis. This is my x-axis. That's my sine angle 40 degrees, and this is my y-axis. Sine 40 degrees equals to P, that's same as P over 1. Therefore, fitting in the values in my diagram, I have the trigonometric ratios. So Katua, sine is the same as opposite over hypotenuse. My opposite here is my P, that's the side facing the angle. The hypotenuse is 1. To find the adjacent, I'm going to use my Pythagoras theorem, which states that the hypotenuse squared equals to the sum of the square of the other two sides. Therefore, my hypotenuse, which is 1 squared, equals to x squared plus y squared, that's b squared. You're making x the subject of formula. I have x squared equals to 1 squared minus b squared. Therefore, x equals the square root of, going to find the square root of both sides to cancel the square for the x, 1 minus p squared. So if I slot that back into the diagram, I have my x, the size of my x-axis, to be 1 minus p squared. Going back to the A part of the question, in order to find sine 140 degrees, I have sine 140 degrees. Reducing that, if I go back to my cast diagram, I'm going to draw a sketch here. In the first quadrant, the value of theta, I have 360 degrees plus theta, or 90 degrees minus theta. That will help me in my reduction. In this quadrant, I have 180 degrees minus theta. That's the second quadrant. This is my first. This is my second quadrant. This is my third. And this is my fourth quadrant. In my third quadrant, I have 180 degrees plus theta. And in my fourth, I have 360 degrees minus theta. If you go back to the question, 140 degrees fall in the second quadrant. So the reduction code I'm going to use will be 180 degrees minus theta. Now you need to ask yourself, what value will I subtract from 180 to give me 140? That will be 40 degrees. And if you check, the value of sine theta in my second quadrant is positive. So reducing, I have sine 40 degrees, that will be equal to, we've been told that sine 40 degrees is P, so that's P. Therefore, sine 140 degrees equals to P. Going to the second part of the question, I have B, find sine 220 degrees. If I go back to my cast diagram, sine 220 degrees, that's falls in the second quadrant. Now that's more than 180, so that falls in the third quadrant. So using the reduction formula, I'm going to have sine 180 degrees. Now to find the value I'm going to add, if I deduct 220 degrees, deduct 180 degrees from 220 degrees, I'm going to have 40 degrees. So that will be plus 40 degrees. You must always double check to see that 180 degrees plus 40 degrees will give you 220 degrees. However, because it's located in the third quadrant, the value of sine is negative. So reducing, this will give me minus sine 40 degrees, which is equal to, we've been told that sine 40 degrees is P, as shown in the question. So that will be equals to minus P. The C part of the question says, find sine minus 140 degrees. To solve that question, I can use two methods. The first method is to use the negative angle rule, which states that the sine of a negative angle will give you minus sine theta. So therefore, sine minus 140 will be equals to minus sine 140 degrees. If I go back to my cast diagram, 140 degrees falls in the second quadrant as shown because it's less than 180. Therefore, using the reduction formula, I have sine 180 degrees minus 40. And because in the second quadrant, the value of my sine is positive, so that remains negative because minus times plus will give you minus. So I have minus sine 40 degrees, which is the same as minus P. The second method is when you have a negative angle, you can add 360 degrees to make it positive. So therefore, if I have sine minus 140 degrees, that will be equal to sine, I'm going to add 360 degrees, putting the 360 degrees in front, minus 140 degrees. That will give us sine 220 degrees. Going back to our cast diagram, 220 degrees falls in the third quadrant. That's third quadrant. Therefore, using the reduction formula, I have sine 180 degrees plus 40 degrees. Note that the value of sine in the third quadrant is negative, so I have minus sine 40 degrees, which is the same as minus P. For the D part, I'm to find cos 50 degrees. Note that if you have an angle, I'm going to show you two methods. The first method, if you have an angle that is acute, if it's cos or sine, you can find the cofunction. The cofunction of cos 50 degrees is the same as sine 40 degrees. Note that if you add 50 degrees plus 40 degrees, that will give you 90. So it's a complement of each other. Therefore, that's the same as P. We know that sine 40 degrees is P, so that is equal to P. That's the first method. The second method is, if I go back to my diagram, this is a right angle, and I know that angles in the sum of angles in a triangle add up to 180 degrees. So therefore, the angle up here is 50 degrees. Using the trig ratios, cos theta equals to adjacent over hypotenuse. In this case, my theta is 50 degrees, so I have cos 50 degrees equals adjacent is P according to the diagram, and my hypotenuse is 1, and that will give me P. So you have two methods to use. For my E part, I'm to simplify sine 50 degrees like I did for cos 50 degrees. Sine 50 degrees, the complement of sine 50, or the cofunction of sine 50 degrees, that's cos 40 degrees, because if I add 50 degrees plus 40 degrees, that will give me 90. Also, I can use the other method by going back to the diagram to say sine theta equals to opposite over hypotenuse. Sine 50 degrees equals opposite for my diagram is the side facing my angle, so that will be root 1 minus p squared over hypotenuse, which is 1, and that will give me sine 50 degrees equals square root of 1 minus p squared. So the last part of my question, to find tan 220 degrees, I have tan 220 degrees equals to, if I go back to my cast diagram, 220 degrees falls in the third quadrant, and if you check the reduction formula, that will be tan 180 degrees plus, to get to 20, I'm going to add 40 degrees. The value of tan in the third quadrant is positive, so that will give me tan 40 degrees. Tan is the same thing as opposite over adjacent for my trig ratios, so therefore tan 40 degrees, going back to my first diagram, for 40 degrees, opposite 40 degrees, I have p over adjacent, which is square root of 1 minus p squared. 1 minus p squared. Thanks for watching. Bye.